So today we are doing the Quiz 2 review for Chapter 6. So there were quite a few things that we did in here. First thing we did before this quiz was simplifying complex fractions, which was a lot like solving rational equations because LCDs were a big part of it. Now, I'm not going to go through and read through all of this. This is just a refresher for you. So, if you forgot how to simplify complex fractions, make sure you look through these steps. The idea of finding the LCD, multiplying by the LCD, simplifying each fraction. All of this is what we did first. So this is probably the stuff that you'd forget the most. So make sure you go back and review it and read through the steps. And if that doesn't help, then make sure you go back and look at those first two videos that were after Quiz 1. Other than simplifying complex fractions and solving rational expressions, remembering that equations. Don't forget that solving the equations actually has two methods. We can either cross-multiply or multiply by the LCD. So remember that you need to identify that based on the number of fractions, and you know you're going to be doing an equation if there's an equal sign. So these only apply to ones with equal signs. This is that fraction within a fraction piece. And then the other thing we did was dealing with synthetic division, which had other uses as well, so you'll want to review that. Now, remember, you do not have to watch through this entire video of me talking through it. You could fast forward and watch through the ones, watch it in fast forward to see each piece done, but to me, the most useful thing would be try every single problem on your own first. That's definitely something you have to do no matter what. And then I would just check your answers using the video. So I'd fast forward, look at the answer. If the answer is the same as yours, then fast forward to the next answer. And only watch the ones that you did not get correct. That would be the most efficient use of your time. So looking at problem number 1 and problem number 2, actually, these are both complex fractions because there's fractions within a fraction. So because it's a complex fraction, we are going to have to find the LCD and multiply by the LCD to solve. So identifying what methods you're using is going to be really important on this quiz. So complex fractions automatically means LCD. So that means we have to try to factor all the denominators. Well, we can only factor it if there's a plus sign within the denominator or a minus sign, and there's no pluses or minus here, so we don't have to worry about factoring. So instead, we just have to make sure each piece is part of our LCD. So we're going to have an X as part of our LCD, we're going to have a Y as part of our LCD, and then remember, with LCDs, we take the highest exponent we see. So the highest exponent on X is 2, so LCD is X squared. Highest exponent on Y is a 2, so Y squared. So my LCD is X squared, Y squared. Then we go through and we start our process, right, where we bring over our first fraction and we multiply that by our LCD, and then we box it in. Then we bring over our next fraction, the minus the 6 over y squared, and we multiply that by our LCD, x squared, y squared, and we box that one in. Do the same thing on the bottom. Bring over the 1 over x, multiply that by x squared, y squared, box it in, bring over the plus and the 2 over y, and multiply that by our LCD, x squared, y squared, box it in. Then we can go ahead and we can simplify each box. So, looking at this first box, the x squareds would cancel, leaving me with a 4y squared. Bring down your minus sign. Here the y squareds would cancel, leaving me with a 16x squared. Then we look at the bottom. Well, in this box there's nothing the same on the top and the bottom, but I can just combine my numerators together, which would be 1x squared y squared over x, and then we can reduce that, right? So we would combine our x's together by subtracting, so 2 minus 1 is 1. So really I would just have x y squared, because it would be x to the first. So now this is xy squared. Bring over our plus sign. Next one, the same idea ends up happening. Nothing really cancels. So we have 2x squared y squared over just a plain y. We can reduce our y's, so this is 2x squared y. And I probably should have written that fraction a little bit more towards the middle to make it easier to do our next step, which is to factor. So I'm just going to recopy my fraction down here. That way I have space to factor above and below it. So first thing we do is we look for a GCF, and in this case there is a GCF of 4, so be careful. A lot of you will want to split this right away, but there is a GCF of 4, so we have to factor that out first. So we're going to divide each piece by 4, giving us y squared minus 4x squared. Then we have to try to factor that again, and we can factor this one because you should look and see they're both perfect squares having their differences. So this becomes y plus 2x, y minus 2x, and we still have our GCF of 4 out front. Now I know I can't factor this any further because there's no squareds, and we already took out our GCF. So my new numerator is 4y plus 2x, y minus 2x. Then I need to factor my denominator. Again, we should look for a GCF first. And in this case, there's an x in both of these. And because we're doing a GCF, we take the smallest exponent. Remember, LCD, largest exponent, GCF, smallest exponent. So I just take an x. We don't take the squared. And again, we have y's in both, and we take the smallest exponent of y. So I need to divide each one of these by xy. Pull out our GCF, so the x's would cancel, subtract the exponents, just y, plus 2, y's would cancel, subtract the exponents to get x. Now there's no exponents here, so I cannot go any further, so we have xy, y plus 2x. That allows us to go ahead and cancel out the y plus 2x, leaving us with a 4 and a y minus 2x on top, and an x plus, or not x plus, just an xy in the denominator. And then I'll just draw my squiggly down in order to separate this from our next problem. So our next problem is also a complex fraction. So since it's a complex fraction, that tells me I have to find my LCD, which means we have to factor our denominators first if we can. So x minus 6, there's no GCF, no squared term, so we cannot factor that any further. But this one we can factor, so we need to try. So there is no GCF, but because my first term is a 1, I can think about what multiplies to the last, negative 12, and adds to give me the middle of negative 4. So 2 times 6 would give me 12, and if I wanted to add to negative 4, we can make the 6 negative. So this becomes x plus 2, x minus 6, and that's our new denominator. We cannot factor x plus 2, we cannot factor x minus 6, so those stay the way that they are. So each one of my binomials have to be part of my LCD. So my LCD is an x minus 6, an x plus 2, x minus 6 is already part of it, x plus 2 is already part of it, and so is x minus 6. So here is our LCD. Now we need to start the process of multiplying each piece by our LCD. So we have 7 over x minus 6, and we're going to multiply that by our LCD, x minus 6, x plus 2. Box it in. Bring over our plus sign, and then 5x over x plus 2, x minus 6. Multiply that by x plus our LCD, which was x minus 6, x plus 2. Box that in. This is all on top of 9 over x plus 2. Multiply that by our LCD, x minus 6, x plus 2. Box it in. Bring over our plus sign and our 3 over x minus 6. And multiply that by our LCD, x minus 6, x plus 2. And box that one in. Then we can go ahead and start canceling things out. So the first thing I would go ahead and cancel out would be in the first box, the x minus 6 is canceled, leaving us with a 7, and I'm going to leave space above this time because I forgot to do that last time. So we have a 7 and an x plus 2. Bring down our plus sign, right? Don't forget that this plus sign is here. That'll be especially important when minus signs get involved. So here we can cancel out the x plus 2, the x minus 6, leaving us with just plus 5x. On the bottom, we can cancel out our x plus 2, leaving us with 9x minus 6. Remember to bring down your addition sign in the middle. The x minus 6's cancel, leaving us with 3x plus 2. Okay, and now, unlike this other one, right, we got to this point, we could go and start factoring. You cannot factor this yet. You need to combine everything together and then try to split it up. So we're going to go ahead and we're going to distribute this in to get 7x plus 14 plus 5x. So if I combine those, we can combine our like terms. 7 plus 5 gives me 12x plus 14. So that is our new numerator, 12x plus 14. In the denominator, same thing, we need to simplify it. So 9x minus 54 plus 3x plus 6. Combined our like terms, 9 plus 3 gives me 12x, negative 54 plus 6 gives me negative 48. Now, please be careful here. A lot of you will just try to cancel those 12x's. You cannot cancel them because you need to factor them first. So we would look for a GCF here, and there is a GCF of 2. So we're going to pull a 2 out of the numerator. If we divide that by 2, we'd get 6x. Divide by 2 plus 7. We cannot factor that any further. In the denominator, there's a slightly bigger GCF. 12 would actually go into both of those evenly. So if we divide by 12, we get x. Divide by 12 minus 4. So my new fraction is 2 times 6x plus 7 over 12 times quantity x minus 4. Nothing cancels here, but don't forget that you still need to reduce any outside terms. So 2 over 6 would reduce to 1 over 6. So I'm not going to, or 2 over 12 reduces to 1 over 6. I'm not going to write the 1. So on top we have 6x plus 7. On the bottom we have 6x minus 4. And then that's your final answer. Because again, remember, you cannot cancel these out because one's in the parentheses and one is outside of the parentheses. All right. Moving on to the next page. We have another complex fraction. So because we have a complex fraction, that means we have to find our LCD. And if I'm going to find my LCD, that means I need to factor my denominators if I can. So here there is a GCF of 3, so I'm going to pull out a 3, and then this will be x plus 2, so that's my new denominator. Here, this can factor, because x squared minus 4, those are perfect squares, so it becomes x plus 2, x minus 2. That's the new denominator. X plus 2 has no GCF, there's no square term, so it stays the way it is. So there's only one monomial, in other words, one thing outside of the parentheses, so that has to be part of our LCD. There is an x plus 2. I'm not going to write it again because I already wrote it. And then there's an x minus 2, and again I don't have to write the x plus 2 because I already wrote it. Remember, this LCD is part of like showing your work. It's part of the answer to me as well, because if you can't find the LCD, then nothing else matters. So be sure that you box it in or circle it or something so that I can find it when I'm looking at your work on the quiz tomorrow. Alright, so now we move on to our next step, which is to multiply each piece by the LCD. So 6 over 3x plus 2. We're going to multiply that by our LCD of 3, x plus 2, x minus 2. Box it in. Over our next one, which was 1 over x plus 2, x minus 2. Times our LCD, 3x plus 2, x minus 2. Box that one in. Going to need to extend this fraction over. And then go ahead and don't forget that this time there is a minus sign here, so be very careful to make sure that you bring the minus sign, because remember those tricky minus signs as we do these. So minus 2 over x plus 2, and we multiply that by our LCD, which was 3x plus 2, x minus 2, and box that one in. And then we can start canceling out things in our boxes, right? So the 3 would cancel, the x minus 2 would cancel, leaving me with a 6 and an x plus 2 on the top. On the bottom, our x plus 2's would cancel, our x minus 2's would cancel. So you just have 1 times 3, which is a 3. Bring over your minus sign again. And then the x plus 2's would cancel. Now here, do not just start distributing in because of this minus sign. You're going to have to distribute a minus sign, but you can go ahead and combine the 2 times the 3 because they're both in the box and on the outside. So 2 times 3 is 6, and then we have the x plus 2 as well. So now we need to go ahead and start. And actually, I just realized I canceled that out incorrectly. I should have canceled out the x plus 2's. So this x minus 2 should have still been there. So just make sure you're careful when you cancel things out. So this one should have been not x plus 2, but x minus 2. So now we distribute in, right? Because we have to simplify each piece. So that would give me 6x plus 12 on the top. Here, realize that we're distributing not just 6, but a negative 6. So negative 6 times x is negative 6x. Negative 6 times negative 2 gives me positive 12, and our 3 out front. Combined our like terms, 3 and 12 give me a positive 15 with a negative 6x. So my new fraction is 6x plus 12 over negative 6x plus 15. Okay, then we need to start looking for factoring this in order to simplify. And on the top there is a GCF, and that GCF is 6, so I'm going to pull out a 6, and then we have x plus 2, because dividing by 6 would give me the x plus 2, and we can't go any further with that, so that's my new numerator. Denominator, again, there's this negative, be careful, so we have to pull out a negative, and then 3 goes into both of those evenly, so I'm going to divide each one by negative 3 to get 2x minus 5. I can't go any further with this because there's not a squared term. So we bring that over, and again, look at those outside terms. We can reduce that. 6 divided by negative 3 is negative 2. We still have an x plus 2 on the top, and on the bottom, the 2x minus 5. And that's as far as you can go on that problem. Alright, so now you're going to move on to the next video to start looking at synthetic division.